Diving right in today. We're going deep on a material that's everywhere. You know, the stuff that holds up our buildings, forms the cars we drive, even the pipelines that bring us energy.
Yeah, we're talking hot rolled coils, HRCs. They're kind of a big deal.
They are. Our goal today is to give you a clear picture of what these coils are all about. You know, how they're made, what makes them so versatile, and why they matter so much in global trade.
Basically, we're taking all the technical jargon and turning it into something you can actually understand.
Exactly. So let's start simple. What are hot rolled coils? Like if you had to explain it to someone who's never even heard the term.
Well, at the most basic level, it's steel. But it's steel that's been through a very specific process. You start with these massive slabs of steel, heat them up to over 1,000 degrees Celsius.
Wow, that is hot. Super hot. And then you roll them out under immense pressure until they're much thinner. And to make it easier to transport and handle, they coil it all up.
Makes sense.
Yeah.
But why all that heat? What's so special about rolling it while it's that hot?
It's all about the properties. The heat, combined with the pressure, creates a material that's really strong and durable. Plus, it's a relatively cost-effective way to produce steel, which is a big factor.
So it's basically a win-win. Strong, durable, and affordable. No wonder it's used everywhere.
Exactly. Think construction, beams, columns, all that structural stuff. Then there's automotive. Tons of car parts start out as HRC. Pipelines, too. Even shipbuilding. It really is amazing how fundamental this one material is.
Listen up if you're wrestling with sourcing materials globally.
Ion International is the only name you need to know.
We're talking top-tier materials, a massive network, and years of proven success.
Seriously, the biggest players trust us, shouldn't you?
And for steel, Metal Movers is your instant online powerhouse.
Unbeatable prices delivered straight to you. It doesn't get better than this.
Don't even waste your time looking anywhere else. Contact us first.
Visit our website, shoot us an email, you will not regret it.
We're not just saying we're the best, our clients know it. Okay, so the source doc dives into a bunch of key characteristics. One of the first things it mentions is affordability. HRCs are cheaper than cold-rolled steel, right? Why is that? Well, mainly because of the process. Hot rolling requires less energy and fewer steps compared to cold rolling, so naturally the production costs are lower.
So if you need something that's strong and cost-effective, hot rolling is the way to go.
Exactly.
Now, another thing the doc notes is a slight surface scale or roughness. It kind of makes sense given the whole hot aspect of the process.
Right. That scale is a layer of oxides that forms naturally when the hot steel is exposed to air as it cools. It's just part of the process. Now, for some applications, it's not a big deal, but if you need a smoother surface, say for painting or precise forming, you have to remove it.
And how do they do that?
Usually through a process called pickling. They basically bathe the steel in acid to get rid of that oxide layer.
Interesting. So it's a bit of a trade-off then. Lower cost, but maybe not the prettiest surface right out of the gate. Now, two words that come up a lot are strength and formability. Can you break those down for our listeners? Like, what do they actually mean in practical terms?
Sure. Strength is pretty straightforward. It means the material can withstand a lot of force without breaking or permanently bending. Think about a steel beam in a skyscraper. It needs to be super strong to hold up all that weight.
Makes sense. What about formability?
Well, formability refers to how easily you can shape the steel. Can you bend it, mold it, stretch it without it cracking? HRCs are great because they're strong, but they can also be worked into all sorts of shapes.
So that's why they're so versatile. You can use them for everything from massive construction projects to small, intricate parts.
Right. It's that combination of strength and workability that makes them so valuable.
Got it. Now moving on to some specs. The document mentions a wide thickness range for HRCs from 1.2 millimeters all the way up to 25.4. The most common thicknesses, though, seem to be between 1.5 and 16 millimeters. What's the reason for that range?
It's all about the different applications. Thicker coils are obviously needed for heavy-duty stuff, like bridges and large buildings. Thinner gauges might be used for things like car panels or less demanding structural components. The cool thing about hot rolling is that it can produce this whole spectrum of thicknesses pretty efficiently.
And the width also varies, from 600 millimeters to 2300. Is that mostly about making sure you have the right size for the final product?
Yeah, basically. The width of the coil limits the size of the parts you can make from it. So if you need a really wide piece of steel, you need a wider coil. Makes sense, right?
Absolutely. Now, this next spec is pretty mind-blowing. Coil weight. We're talking 5 to 25 metric tons. That's a lot of steel.
Oh, yeah. It's huge. It's all about efficiency, though. Bigger coils mean you can produce more stuff without stopping the manufacturing process. But of course, it also means you need some serious equipment to handle them.
Yeah, I can imagine. Like some pretty heavy-duty cranes and stuff.
Mm.
Okay, last bit on specs, we have coil dimensions. The inner diameter is usually 508, 600, or 762 millimeters, and the outer diameter can go up to 2100 millimeters, but it's typically between 1000 and 1800. Are these standardized for a reason?
Definitely. It's all about compatibility with the machines that process these coils, the things that unwind them, cut them, and shape them into the final products. Having these standard sizes just makes everything run smoother.
So it's like a universal language for the steel industry. Makes sense. Now let's get into the nitty-gritty of commercial grades and standards. It seems like this is where things get really specific.
It is. It's all about making sure you're using the right steel for the right job. Different applications need different properties, right?
Right.
So these grades basically categorize the steel based on its characteristics. You have commercial quality, or CQ, which is sort of the all-purpose HRC, good for general construction and fabrication work.
Okay, so that's like the standard go-to option.
You could say that. Then you have drawing quality, or DQ, which has a better surface finish and can be shaped more easily. Good for bending and moderate forming processes.
Makes sense. And then there's deep drawing quality.
Right, DDQ. That's for applications where you need to really stretch and form the steel without it tearing. Think of complex car parts with lots of curves.
Oh, I see. That makes a lot of sense. What about structural quality?
Structural quality is specifically designed for, well, structures. Things like buildings, bridges, anything that needs to support a lot of weight.
So that's the heavy-duty stuff.
Yep. And finally, there's high-strength, low-alloy, or HSLA. This one's really interesting.
Yeah, I was curious about that one.
So HSLA steels have these small additions of other elements, things like manganese, niobium, vanadium, that make them even stronger.
So it's like steel on steroids.
Kinda, yeah. You get more strength without adding much weight, which is a huge advantage in a lot of applications.
Interesting. Okay, now, the document also lists a ton of international steel standards. ASTM, EN, JIS, all sorts of acronyms. Why are these standards so important, especially in a global market?
Well, imagine trying to buy steel from a different country without any common language or set of rules. It would be chaos, right?
Yeah, for sure.
That's where these standards come in. They're like a universal language for steel. They ensure that everyone's on the same page, no matter where they are in the world. It makes international trade a lot smoother and ensures a certain level of quality.
So if I'm buying steel from, say, China, and it meets a specific EN standard, I know it's going to be good quality, even though it wasn't made in Europe.
Right. The standards set the bar for everything from the chemical composition to the strength and durability of the steel. So no matter where it comes from, you know what you're getting.
Got it. Can you give us a couple of specific examples of what these standards look like in the real world?
Sure. Take ASTM A36, for example. That's a common American standard for structural steel. It's used in all sorts of buildings and bridges. If you see that a piece of steel meets ASTM A36, you know it's going to be strong enough for its intended purpose.
And there are similar standards from Europe and Japan.
Right. EN 10255 is a big one in Europe, covering a range of structural steels. In Japan, you have JIS standards like SS400, which is a common structural steel grade. These standards are everywhere.
Okay, I think I'm starting to get the hang of the standards thing. It's all about making sure everyone's playing by the same rules, regardless of where they're producing or buying the steel. Tired of the sourcing struggle? Ion International has your global needs covered.
Need steel like yesterday? Metal Movers delivers top deals online, lightning fast.
We're talking years of experience serving industry giants. We know this market inside and out.
Get the best, fastest sourcing and unbeatable quotes. Visit our website or email us now.
Now let's talk about surface finish and edge conditions. We already touched on the mill finish, which has that oxide scale. What are some of the other options?
Right. So besides the standard mill finish, you have pickled and oiled, or HRPO. That's where they remove the scale with acid and then coat the steel with oil to prevent rust.
So it's a cleaner surface, ready for painting or whatever else you want to do with it.
Exactly. Then you have HSLA again, but this time under surface finishes.
Wait, I thought HSLA was a grade of steel.
It is. But remember, HSLA steels can have different surface finishes. It's not like one excludes the other. You can have HSLA steel that's mill finished, HRPO, or something else.
Okay, that makes sense. It's like ordering a burger. You can choose your patty and your toppings separately. What about weathering steel? I think I've seen buildings with that kind of rusty look.
Yeah, weathering steel, also known as Corten steel, is designed to rust in a controlled way. It forms a protective layer that actually prevents further corrosion.
So the rust is actually beneficial. That's pretty cool.
It is. It's often used for outdoor structures where you want that rustic aesthetic and low maintenance.
Very cool. The source also mentions dry and descaled finishes. Those seem pretty self-explanatory.
Yeah, dry just means there's no oil coating. Sometimes that's preferable for certain applications. And descaled means the scale has been removed, but not necessarily with acid. They might use mechanical methods like grit blasting.
Got it. Now, what about edge conditions? We have mill edge, trimmed edge, and slit edge. Why are there different edge types?
It's all about precision and how the steel will be used. Mill edge is the raw edge, straight from the rolling mill. It can be a bit rough and uneven. Trimmed edge means they've cut the edges cleanly to create a consistent width. And slit edge refers to a wider coil that's been cut into narrower strips.
So it's basically about providing the right size and edge quality for the specific application. Makes sense. All right, let's move on to trade and export information. The document mentions HS codes for HRC. Can you explain what those are and why they matter to our listeners?
Sure. HS codes, or Harmonized System Codes, are basically a global system for classifying traded goods. They're used by customs authorities to track trade and determine tariffs. For you, listener, they indirectly impact the cost of goods made with HRC because tariffs affect import prices.
So if I'm importing HRC, I need to know the HS code to figure out how much I'll have to pay in tariffs.
Right. And those specific codes help categorize different types of HRC.
Okay, got it. Now, what about all those essential documents listed in the source? Mill test certificate, certificate of origin, and so on. What's the purpose of all that paperwork?
It's all about transparency and accountability. Think about it.
Yeah.
You're buying a massive amount of steel from another country. You need to know exactly what you're getting right.
Right.
So the mill test certificate gives you all the details about the steel's properties, like its chemical composition and strength. The certificate of origin proves where it was made, which is important for tariffs and trade agreements. Then you have the packing list, the invoice, the bill of lading, maybe even an inspection certificate. It's all about making sure the deal is legitimate and that you're getting what you paid for.
Wow, it sounds like a lot of paperwork, but I guess it's necessary when you're dealing with such a valuable commodity.
Definitely.
Okay, now, how do these giant coils actually get shipped around the world?
Usually in those big shipping containers you see on cargo ships.
Yeah, okay. Makes sense.
And the source doc mentions specific weight limits for 20-foot and 40-foot containers. It's usually around 20 tons for the smaller ones and 25 to 27 tons for the bigger ones.
Got it. So they load up these containers with HRC, ship them across the ocean, and then unload them at the destination port.
Exactly. It's a pretty efficient system, all things considered.
Okay, now let's zoom out and look at the global market dynamics. The document lists major producers from all over the world. It's a truly global industry.
It is. You have the big players from China, like Baowu, HBIS, Shegang. Then there's Japan with Nippon Steel, South Korea with POSCO, Europe with ArcelorMittal, India with Tata Steel and JSW Steel, the U.S. with Nucor and U.S. Steel. You even have Russia with Severstal and NLMK, and Brazil with CSN and Usiminas. Steel is produced pretty much everywhere.
Wow, it's amazing how interconnected the world is when it comes to something like steel production. And the source also mentions regions known for low-cost production: China, India, Russia, and some others. Why is it cheaper to produce HRC in those places?
Well, it's a mix of factors. Access to cheap raw materials is a big one. They might have abundant iron ore and coal, which are the key ingredients for making steel. Labor costs can also be lower in some of those regions. And then there's the scale of their operations. Some of these companies are just massive, so they can produce steel more efficiently, which drives down the cost.
So it's not just one thing, it's a combination of factors that give them a competitive edge. And then we have the top importing regions: the USA, the EU, the Middle East, and Southeast Asia, and the top exporting regions like China, Japan, South Korea, Germany, India, and Turkey. What drives these trade flows?
Well, it's basic supply and demand, really. Some regions have a huge appetite for steel, but limited domestic production. Others have excess production capacity and are looking for buyers. Plus, there are all sorts of logistical considerations like shipping routes and trade agreements that influence these patterns.
Okay, now, the source also mentions regions known for premium quality: Japan, South Korea, the EU, and the US. Does that mean HRC from other regions is automatically lower quality?
Not necessarily. It just means those regions have a reputation for producing steel that meets very specific and demanding requirements. Think automotive or aerospace, where precision and consistency are absolutely crucial. But it doesn't mean that steel from other regions can't be high quality too. There are plenty of producers around the world making great steel. It's more about specialization and meeting specific customer needs.
Makes sense. Now, for those involved in the steel trade, the document lists some global price benchmarks, like the S&P Global Platts HRC Index. What are those, and why do they matter?
Think of them like stock market indices, but for steel. They track prices and market trends so that buyers and sellers have a reference point for negotiating contracts.
So if I'm a steel trader, I can use these indices to get a sense of what the going rate for HRC is.
Exactly.
And finally, in this section, there are some HRC trade routes listed. China to Vietnam, India to the UAE, and so on. Are these just random routes, or are there specific reasons why those routes exist?
There are definitely reasons. Usually it's a combination of geography, trade agreements, and the specific needs of those regions. For example, China is a massive steel exporter, so it makes sense that they would ship a lot of HRC to nearby countries like Vietnam.
Makes sense. Okay, now let's talk about packaging and handling. These coils are huge and heavy, so I imagine they need some pretty specialized packaging.
They do. The source document mentions eye-to-sky and eye-to-wall packaging, which refer to the orientation of the coil. Basically, whether it's standing upright or lying on its side. They use steel strapping to secure the coil, and they often apply a protective coating to prevent rust. Then they wrap it all up in a protective layer and put it on a skid or pallet to make it easier to move.
Wow, that's quite a process just to package it up. And then there's storage requirements too, right?
Right. It's important to store HRC in a covered warehouse to protect it from the elements. You also have to be careful about stacking them too high because the weight can damage the coils at the bottom. And good ventilation is important to prevent condensation and rust.
Makes sense. You wouldn't want all that steel to rust before it even gets used. All right, now, can you give us a simplified explanation of the actual manufacturing process?
Sure. It starts with these thick slabs of steel that get heated up to super high temperatures, like 1200 degrees Celsius. Then they're rolled out thinner and thinner by these giant rollers. As the steel cools, it forms that oxide scale we talked about. If they need a cleaner surface, they might pickle it in acid to remove the scale. And finally, the steel is either cut into sheets or coiled up.
So it's basically a lot of heat and pressure to transform those slabs into the final HRC product. Now, what about quality control? Are there certain defects that can occur during the manufacturing process?
Oh, yeah, for sure. You can get edge cracks, surface scratches, laminations, shape defects, and of course that surface oxide scale if it's not properly treated.
And how do they ensure the quality of the HRC?
Well, there are different quality certificates like EN 10204, Type 2.2 and 3.1, and also ISO 9001. These certificates basically prove that the steel meets certain standards and that the manufacturer has good quality control procedures in place.
So if I'm buying HRC, I should look for those certifications to make sure I'm getting good quality material.
Exactly. And then there are different quality categories too. Prime, secondary, and rejected defective. Prime is the best quality. Secondary might have some minor imperfections, and rejected is, well, rejected.
Makes sense. And then the document mentions key quality parameters like thickness, width, flatness, and surface quality, along with acceptable tolerances. Can you explain why those tolerances are so important?
Sure. The tolerances define how much variation is allowed in those parameters. For example, if the thickness tolerance is plus or minus 0.1 millimeters, the actual thickness of the steel can be 0.1 millimeters thicker or thinner than the specified thickness.
And why is that important?
Because if the thickness is off by too much, it could affect the strength of the steel or how well it fits with other parts.
Got it. So tolerances are all about making sure the steel is consistent and meets the required specifications. All right, let's talk about mechanical properties. The document lists yield strength, tensile strength, and elongation. Can you explain what those are in simple terms?
Okay, so yield strength is how much force the steel can withstand before it starts to permanently bend or deform. Think of it like how much weight can a beam hold before it starts to sag. Tensile strength is the maximum force it can handle before it breaks completely, and elongation is how much it can stretch before it snaps.
So engineers need to consider all these properties when choosing the right HRC for a specific application.
Absolutely. They need to make sure the steel can handle the stresses it'll be subjected to. You wouldn't use the same steel for a skyscraper as you would for a car door, right?
Great. Now the source document gets really specific and breaks down end user requirements by sector. It looks at construction, pipe manufacturing, and automotive.
Yeah, and it's interesting to see how the needs vary. Construction obviously needs strong, durable steel. They often use structural grades like S235JR to S355J2 in Europe, or A36 and A572 in the US. Pipe manufacturing needs steel that can be easily formed into pipes, so they often use specific grades and sizes for that. And the automotive industry has its own set of requirements, focusing on formability, surface quality, and weight reduction.
So it's all about choosing the right tool for the job. And speaking of tools, the source mentions value-added services that traders can offer, things like pickling, slitting, cut-to-length, and blanking. What are those all about?
Basically, it's about taking that raw HRC and processing it further to meet specific customer needs. Pickling removes the scale, slitting cuts the coil into narrower strips, cut-to-length creates sheets of a certain size, and blanking punches out specific shapes. These services just make it easier for manufacturers to use the HRC in their production processes.
So it's like a one-stop shop for all your HRC needs. And finally, product comparisons. It compares HRC to cold rolled coils, galvanized steel, and steel plate. Can you give us a quick rundown of the key differences?
Sure. Cold rolled coils are smoother and have tighter tolerances than HRC, but they're also more expensive. Galvanized steel is coated with zinc to prevent rust, so it's good for outdoor applications, but again, it costs more. And steel plate is a flat, thicker format compared to HRC. It can be stronger, but it's also more expensive.
So each product has its own strengths and weaknesses. It's all about choosing the right material for the job.
Exactly.
All right, we've covered a lot of ground today. From the basics of what hot rolled coils are to their global market dynamics and even their mechanical properties. It's amazing how much goes into this seemingly simple material.
Yeah, it's pretty fascinating when you think about it.
So what are the key takeaways for our listeners?
I think the biggest one is that hot rolled coils are a fundamental building block of our modern world. They're everywhere. They're strong, durable, versatile, and relatively inexpensive.
And hopefully now our listeners have a much better understanding of what goes into making them and why they're so important.
I think so.
We're excited today to showcase Ion International and Metal Movers, and really how we're revolutionizing the way businesses secure essential materials. And our mission fundamentally is simple. Make your material sourcing efficient, cost-effective, and frankly, utterly stress-free.
You've got Ion International providing access to that broad range of high-quality materials, leveraging those established global networks.
Right.
And then you have Metal Movers offering a specialized, highly efficient online solution just for steel procurement.
Metal Movers gives you, the user, a direct, transparent portal. You see competitive deals from trusted suppliers delivered straight to your doorstep. Imagine the time savings, the cost savings, no more constant haggling, just efficient sourcing right there at your fingertips. And look, we genuinely invite you to connect with us directly if you're looking for better quotes, if you're looking for a more streamlined, more reliable way to source your materials.
Which many are.
Which many are, indeed. We are truly confident that Ion International and Metal Movers together can deliver exceptional value. Let's talk. Let's explore how we can simplify your sourcing and help drive your success.
Yeah.
All right, that's it for today's deep dive. Thanks for listening.
See you next time.